Welcome to the Healthy Seas podcast, a show about what we need to do to have just that, healthy seas and a healthy future. I'm your host, Crystal DiMichelli, and in each episode, we talk about the problems facing the seas and oceans and the solutions we have to fix them. Come on in, the water's fine. Scientific diving is a kind of diving separate from, say, recreational or commercial diving, and involves collecting data or doing experiments underwater. To be a scientific diver, you need to have a certain skill set, and today's guest, Edd Stockdale, can help you get that skill set. He's a coordinator with the Finnish Scientific Diving Academy. Hi, Edd. Thank you for joining me on the Healthy Seas podcast.
No, thank you very much for inviting me. It's quite exciting to be here, and especially with a list of the very astute divers that you have before me as well. So it's quite an honor, and I look forward to a conversation here. So.
Yeah, I bet we're going to have a lot of interested people in what you do because it's really neat. And so let's dive in. What is scientific diving, and why do you need school for it? Isn't it enough just being a scientist and knowing how to dive?
Scientific diving is pretty much, it's the use of diving equipment to gather data or samples or carry out experiments underwater. So if you're not actually gathering data or you're not collecting scientific information or samples or such, then it's not really scientific diving. It's something else that might be just as important. But the training involved in scientific diving is, a lot of it is techniques based because it's quite task loaded. So the sampling methodologies, also the planning, the team communication components of it, it's quite an important component. And by being just a scientist and knowing how to dive, I mean, this is a response we get quite a lot, but actually when people go through the training, they realize why. It's the same as if you're being a scientist and you wanted to go to do a certain lab technique, or you wanted to run a certain type of genetics analysis machine, you still need training. You can have the theory of that science, but you don't have the actual sort of hands-on skills. So scientific diving, a lot of time, is just another tool in a scientist's array of skills that they can use to address their research questions or investigate their area of expertise or challenge their hypotheses as such. And the whole thing about the training is the better trained you are, the better the results you're going to get as part of it. So it's probably the best way to go about it. The key thing with scientific diving is that just by being there in the water, the diver is going to have an influence on the environment around them. And that means that you're going to skew replicates of data, or you can have an effect on whatever it is that you are studying at that time. So having improved scientific diving skills means that you get better data, which in the long run is the goal. So if you're not getting data, you're not doing scientific diving.
And how did you come to be a scientific diver?
So my scientific diving career, I was originally I was a marine biologist. So I wanted to be a marine biologist since I was really small. And then I ended up going to university. I did that. I worked as a research assistant in some labs. And then I moved to do some postgraduate research studies working on marine mollusks. And then from there, I sort of drifted into the diving world. I lived the lifestyle dive bum for a couple of years, just sort of in one of those tropical destinations that everyone dreams of. And I got quite rapidly bored of just doing the same style of diving again and again. I went back into volunteering for some conservation projects, and I ended up working as a scientific sort of sampling diver on a research station in Indonesia, where I then became rapidly the dive officer, training students in basic scientific diving techniques, assisting with larger scale projects. And then from there, it sort of spiraled onwards. One of my main interests in my own spare time is sort of more advanced technical diving aspects and rebreathers. And I saw a big opportunity to advance scientific work with these techniques, the opportunity to go deeper or go longer or have more opportunities in specific environments to gather data. And then from there, it just sort of spiraled. I became more of a facilitator for the science rather than a researcher myself, supporting various projects around the world and doing the dive logistics and the land dive management. So I've ended up basically being a dive safety officer for probably going on 12, 15 years now. And now I've ended up running this new training academy for scientific diving, as well as still doing projects. So that's about Yeah, it's basically 2 decades worth of development from when I started as a marine biology student to ending up nowadays where I'm running the training academy and a lot of interesting and exciting and also quite difficult opportunities and jobs along the way. So,
What is the current preparation that a student in marine biology comes out with in terms of diving?
oh, I mean, that is a very wide answer, really. It really depends on where you are, to be honest. What university, even within the same country, or and then countries around the world. More and more these days, biological programs or marine biology programs don't have a diving training aspect in it. I mean, you're lucky at a lot of them, they have snorkeling. There are specific institutes that have very good diving programs integrated. There's some in America, there's some in Canada, there's a couple in the UK, and places like that. But most often, in a core sort of component for a marine biology student or a marine researcher in any field, there's very few opportunities in their core curriculum to get training in these fields. They usually have to take it as an elective or pay for it separately. Field courses and sort of field skills are seen like they're expensive to run, so universities are cutting funding more and more for them worldwide, which is a big shame. So yeah, at the moment, the current preparation can vary according to the institute that you're at, but a lot of the time it doesn't exist.
It kind of seems silly to not train a student of marine biology in the tools that you need to be a marine biologist. I mean, maybe not necessarily, but it does seem like there's a disconnect there.
Yeah, it's a sad thing because not having field skills, regardless, actually, even if it's diving or terrestrial skills, removes the capabilities of these graduates when they finish to have access to that. And then we what we do is we find more and more people are going to end up in they're going to end up in theoretical areas or lab-based research, and there's a huge demand for people with field skills. I don't think every marine student needs to do a diving based training, but I think the option of having it there is quite important for the future of research in these fields.
Yeah, I can see the importance of having this dive training as an option.
I think the opportunity to study it would make it really good. Just the same way that if you do a zoology or a biology degree, you cover both ecology and taxonomy, and you cover little bits of everything within a bachelor's degree, depending on the program you're running through. And then these field skills specialities, if they are of interest to a student, would be really useful. In terms of changing your career, I mean, from my personal experience from where I am based, it definitely changes people's careers. Like the opportunities that are out there for qualified scientific divers with certain specific like occupational qualifications within Europe, especially within Finland, mean that they can change the full direction of what they wanted to do. In other places, it really depends on the goals of the individual more than anything.
Are there more people going into ocean and sea related careers than in the past?
I was actually having this conversation the other day with a colleague of mine that works at another institute, and we had this sort of joke going on. It's not a joke actually; it's kind of the truth that we're in a new age of ocean exploration. We really are. In the last couple of years, there is a lot of very exciting projects and organizations and institutes developing that don't fall into the sort of normal, classical government funded, university funded research areas. And in addition to that, there's a very, very heavy focus with conservation groups and citizen science diving as well. So people that want to be involved with answering these questions that are related to the state of our seas and oceans and trying to work ways to overcome it. So yeah, I think there are more people paying attention and there are more people trying to get involved. I think the sort of traditional uptake in terms of the number of people going through the graduation of marine biology, for example, and then going into a job working in that area directly is less. So it's not less than it was. It's just less than less in the uptake than it is in the sort of the wider scheme of things. I mean, there's some very very exciting projects that have started just even last year, like Ocean Census. You've got the Schmidt Foundation's doing some amazing work. Ocean X is really picking up awareness of what's going on in our oceans, and then you've got, I mean, for example, HEalthySeas, as I have sat here, and the ghost diving and components of that. So there is a very, very big interest of people looking to work within our marine environments in some way towards conservation or science or an overlap of the two. Um, but that's just my overall opinion of it. I don't actually have solid stats for that, but that's my feeling of it at this point in time, I should say.
Now, maybe I missed this part, but you said something about people after graduating, they're less going into work,
No,
to
there's a
jobs?
less of an uptake. There's a less of an increase. So there's still an increase of people going into those fields, but it's the increase relative to the non-graduate direction, as I'm saying. So there's more people from a sort of alternate pathways going into ocean science and conservation related work, whether it's through the blue economy drives the EU, or whether it's conservation based projects, or whether it's NGOs, or whether it's philanthropic funded projects, than the traditional pathway. I think the traditional pathway is still attracting a lot of people and it's still increasing, but it's just not it. The big upscale is not coming from finish high school, go to university, do a marine biology degree, go into a master's, go into a PhD, then go into academia. The route way is a little bit different now. People are finishing high school, they move into a totally different field, and then they decide they want to go into ocean conservation or marine research, and they come back and do a master's, and then they go off sideways again, and they end up working for an NGO or a privately funded research institute and things like that. That's becoming more common now as a route direction, in my feeling, from the fields and areas that I work in. But like I said, I don't have actual hard numbers, so it's very unscientific of me. I should put it that way.
Yeah, but you're pretty connected into that world through the academy that you work at. Like, how many academies like yours are there? Especially now that there is this increased uptake that you mentioned, we could use more people who are trained in scientific diving. So, is it just your academy or are they all over?
There's various pathways into the scientific diving training. A lot of institutes have their own wing or like their own department, the scientific diving department that's within their university that trains their students and only their students. And that will be someone's job who also has some other jobs in the university. This is very common in the US system, where they have a very, very different regulatory body to, say, the European system. So there are various organizations or institutes that have their own scientific dive training schools within Europe as well. There's not a huge number, to be honest. I mean, we're scattered very, very thinly. For a larger scale dedicated training academy like the Finnish Scientific Diving Academy, which I run, there's less of those again. There are still a few scattered here and there around the world that run training programs at sort of a national level to address a shortage within the institutes of that country. For example, Australia, they're linked in with a commercial diving school. They train there rather than each university training their own divers. In other countries, the national governing body will actually do the training rather than the institutes themselves. In my case, I'm based at a university, but the facility, or the FSDA, is actually a national training facility now. So I do the training for everybody from all the different universities rather than each university investing in their own expertise. But yeah, it's not a hugely common thing as such, is to have a larger scale training academy like this.
Yeah, I imagine it's not cheap either. So, I could
No,
understand
definitely
why.
not.
You're based in Finland, where it is a cold water environment. How does that change things? Because I actually used to work for the Smithsonian Tropical Research Institute that had a lot of scientific diving in the tropics, but that's an entirely different world. How does the cold water change things?
Yeah, I mean that's one of the specializations of where we are for obvious reasons, because our coastal water is all the Baltic Sea. Cold water challenges a lot of components of just your task loading and your handling of the equipment, mostly because we're wearing thicker undergarments, we've got dry suits, we have dry gloves. Just managing the equipment, like the fiddly little gear of the equipment, clips and scientific gear, writing, everything else. Not only that, we're also linked into generally lower visibilities in the training itself. So you have more difficulty with communication within the teams. That's sort of the Baltic environment that we're training in. In addition, like we sort of specialize in even more extreme conditions, like colder. areas like the polar regions, where we're also managing the surface component. I mean, dive gear is generally not designed to be used in sub-zero temperatures for obvious reasons, but it still has to be used in those areas, like managing the equipment on the surface, keeping the divers warm and physically in a state that they can be involved in a project. That's all part of the training component of what we do. And I mean, it's not massively difficult, really, to be honest. Maybe I'm just a little bit biased because I spend all my time in cold water these days, but if you get used to using dry gloves and losing dexterity and just having more equipment on you, then it becomes like second nature. But that's the whole point of our training programs. It sort of integrates all that into it so that we can train these divers to be functional, not only scientific divers, but scientific divers for the Baltic regions.
And what are the range of training options that you guys offer?
Yeah, so the Scientific Diving Academy has a core component, which is our occupational scientific diver. This is designed to take someone that is basically an advanced water level diver with limited diving experience and train them all the way through to being a research site supervisor for a project. So it's a 6-week training program that integrates everything from risk management to human factors and team development to scientific diving skills to planning projects to driving boats. So it's a very extensive, long, intensive program, I should say. In addition to that, we have specialist programs. So actually, a couple of weeks ago, we ran our first polar research diving program. We went up to the far north of Finland in the Arctic region to do a training program up there in a frozen lake that we have a research station at that's linked to ours. And we had people from all over the world there for a week-long course learning surface exposure, how to manage the cold with equipment, how to deal with the cold just being on the surface in -20, -30, and all the components of that. And then instead of driving boats, they learned to use snowmobiles to shuttle gear to the site and move gear around, how to cut the ice holes themselves. So that was an exciting program we've just started, and it was a huge success. And it will be continuing in the following years. We've got things like the scientific rebreather scientific diving program. So it's a 4-week program dedicated to training people to use rebreathers in occupational scientific projects. So large scale operations, again, with the risk management, the responses, the differences from using sort of traditional scuba in the shallows and actually deeper range components, using support divers, how to plan for different condition changes and things like that with having divers down. And this is quite an interesting sort of overlap area because rebreathers are becoming a more and more common tool in scientific diving just because they allow the depth in a much safer manner than using open circuit because of the gas resources, but also because they don't disturb the environment in the same way. So you don't scare the marine life in the same way because you're not producing noise with the bubbles and everything else. They also could be used for sort of overhead environments and that without disturbing the roof with bubbles hitting the roof. I was actually on a project in December where we were taking samples in a cave that had a really endangered silicate sponge that lived all across the roof. And you can't go in there with normal scuba because the bubbles destroy the silicate sponge. So we had to go in on rebreathers and do all the sampling and then come out to do that. So there's sort of a very specialized area. It's one of the first European courses to run a dedicated scientific rebreather-based program. So we do that. We've got other specialist courses. So we do full face mask communications, which are used in certain environments, especially like river research or monitoring, because they've got zero viz. So there's no point in being in a buddy system. So they learn how to use a full face mask and a comms tether line, similar to a commercial diving operation, but while still doing scientific work. We have a new program or two that I'm working on at the moment to be launched in 25 or 26 using DPVs, like diver propulsion vehicles, for doing large-scale surveys linked in with geolocation systems like USBL systems. And we sort of also offer specialist consultancy training. So if an organization comes to us and goes, oh, we want to do this, but we don't really know how to plan it, or we don't really know how to use the techniques, we can actually turn around and go, okay, we'll design a training program that will be related to that, and then we'll pull the expertise in. One of that, for example, is 3D photogrammetry, which you were actually talking to Mario and Pascal about a few episodes ago, and doing the photogrammetry training programs with that. So we have a few connections that are very interested in coming in and running programs like that for maritime archaeology people that are looking to learn these skills. So there's specialist programs in sort of all areas, but the core one is this 6-week occupational scientific diver.
What kind of skills are needed for all these different types of diving? And what tools do scientific divers use most often?
Scientific diving, like I said at the start, is just gathering data or carry out experimentation. So the range of techniques or tools can vary very extensively. The core skills, and this is a very modern approach to the scientific diving training that we use. There's various people around the world who agree and they do it the same way. The key component to start with is you've got to have good buoyancy, propulsion, and sort of task management in your diving, because if you don't have that, you're going to start interfering with the marine environment around you. So, for example, if you're going to be taking sediment cores to look at carbon content, like inorganic carbon content, and you have to kneel down each time you take a sample, then obviously you're going to have a direct influence on the sediment that you're sampling. So having core really good diving skills to start with is that, and then team dynamics and team communication, having an understanding of how the human factors, like components of a team, work, and to develop that team to get the most out of your sampling or experimentation is quite vital. I mean, one of the big things I always say right at the start of the program is that compared to your terrestrial biological researching counterparts, you have a very limited amount of data gathering time. I mean, theoretically, you can do 3, 4 dives a day, but occupationally, you can't do that so much because of the risk management component. So let's say you get 2 dives a day and they're an hour each. Of that hour, you've got 5 minutes you lose of that hour either side that you use to get down to the site, find where you are, communicate, yep, we're going to start here, let's go, if you're really good, that is. And at the end of it, you've got 5 minutes of that dive, which you've got to go back up, do your safety stop or any obligatory decompression you've got, and then get out. So you've only got 50 minutes, and that's twice a day. So you've only got 100 minutes a day that you can actually sample. Whereas your terrestrial colleague is off in the forest or out on the beach or in the mangroves, and they can sample for an extended period of time, generally between sunrise and sunset, depending on how motivated they are. Obviously, there's limitations in their area as well, but because of that, you've got to have very good planning skills. You've got to have a very good communication to be able to get the work done efficiently. And that's what we train them as well. The tools that we introduce them to, I mean, the traditional tool that you sort of see with a scientific diving is someone will pull out a transect tape, because doing transects and replicates of transects, that's your sort of almost your stereotypical scientific dive tool. So we train with those basic skills like that. We do a lot of coring because we do a lot of soft sediment work in the Baltic, because there's a large component of soft sediment. We do hard substrate sampling. We do a lot of video documentation, photo documentation training. One of the big things as well we do is, because our course is not biology based, it's biology and archaeological based. So all the biology students learn archaeological techniques and vice versa, because everyone's on the course together. And the advantage of this is they can take something from the other field they may not have been introduced to previously, and they could use it for their own benefit of their research. But it gives them more task loading and interaction. So they learn how to raise artifacts. They learn how to document an artifact on site. We do basic photogrammetry introductions. Lift bagging is a component. We use underwater vacuums like airlifts, things like that. So there's a whole array of different techniques. We just teach what's related to the core research that goes on at our research station and with our associated institutes like Heritage and components like that. But yeah, I mean, I could list tools all day. You can get really, really fancy, or you can get really, 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 really simple. But the key component is you've got to be a good diver first. And so we spend the first week of a program just training everyone to be sort of in good buoyancy, good trim, good propulsion, good awareness of what's going on around them, how to interact with their team, how to have a good culture within a team so that you can get better data.
Paint a picture for me. What does a normal scientific dive look like?
So a normal scientific dive, again, like I said, is quite varied.
Could I frame that question a different way,
No,
you
no,
think
I
would be
think it
better?
is a normal. I could go through a normal scientific dive in the way that I would approach it, because I do archaeological and biological, and pretty much it's the same component. So a normal scientific dive would start with the first thing you've really got to take into account with any scientific dive is that you've got a research question that you're addressing. If you don't have a research question that you're actually doing the dive to work towards, then it's not really well structured. So you'll have an overall goal of the project, and then you'll have the research question that dive is related to, whether that be is what's the ecological like component to this, or do we need to sample that, or do we need to take a picture or a photogrammetry model of this? Because it's going to answer the question in this way. So you need that original idea structure first, and that's the overall project that would be involved. Then before the dive goes out, you need to have a plan. Everyone should be sitting together and discussing exactly what it is that we're going to do and how we're going to do it and who's going to do what. Because until you've got all that sorted, it's just a nightmare in the water. And you want all that discussion to happen on the surface when you can sit there and talk and go, right, you're going to go down and you're going to do this. And then I'm going to come in and I'm going to do this. And then you're going to go and do that. And you might even do a dry run, like practice it so you get it into your head, because we're going back to that 100 minutes a day. So you need to make sure you get the best benefit out of this. And a really good team will do this. An inexperienced team won't. After that, you go and set up your equipment, you load the boat, you then go through all your checklists, you record all your data that you need, so related to the diving, so your gas pressures, your time in, your time out, all those components that are going to be related to it. You do all the safety management calls according to your regulations, and you go off. Generally, prior to the dive, much more so than on a recreational dive, you'll have a dive supervisor that's on the boat or on land whose job will be to do the final checklists. And it's not just a body check, you actually have the supervisor will go through the check with the people involved. They'll then get in the water, and that will depend on what environment and what equipment they're using and what regulations you're following. Go down and they will carry out the task at hand, whether it's sampling, whether it's setting up an experiment, whether it's breaking down an experiment, whether it's taking observations or measurements. They'll return to the surface. Everyone will be checked back into the boat. The rest of their gas pressures and other statistics will be taken off them from their dive and their parameters and everything, and then you head back. And then that's the difference here, is the day's not finished at this point, because that was just the sampling. Now we've got to take those samples and process them, or now we've got to take those data points from the measurements or observations and put them into our overall data set so we can start running statistical analyses on them. Or the images that were taken for the photogrammetry model then have to be taken and processed in the computer. So now you're already continuing with the day. I mean, a lot of the time, the diving is only a small component. The larger scale research question is that. In addition, you've then got to go and fill all your gas, clean all your gear, process, hang all that away, and everything else like that. That's sort of the process of a single dive. And if you're involved in a longer scale project, that will be repeated again and again and again and again and again, all the way down. So scientific diving is seen these days. It's become a bit more jazzy these days. It's becoming more popular, and I think that's related into what we were talking about earlier, where there's an increased interest in the state of the oceans and that component of it. And people have this sort of preconception that you've got a transit tape and a wetsuit, and off you go, and you're going to go there, and you're going to measure beautiful coral reefs, and you're going to take a photo of a turtle, and a manta might swim by if you're lucky, and then you're going to wind it all in, and you're going to go up onto your boat, you're going to go back to your beach, and that's it. In reality, you're doing, as with all science, you've got to do replicates. You've got to do it in a strict sort of experimental design manner. And it's quite boring, to be honest. You need to do repetitive components. It's very rewarding, but don't get me wrong, because you have to be focused on the task at hand. You can't. Some people are like, oh, I love fish and I love diving and I really want to be involved in this world. And half the time you don't see anything because you're there doing work on the bottom, and the
You're like
sediments are being
looking at
picked
this
up, and yet
1 square meter.
focused like little square meter. Like, did you see the manta? No, it swam behind me because I was doing work. Not that we have mantas in the Baltic, but or we might. I just never see them. So yeah, a normal scientific dive is it's not just the dive; it's the entire process around it. And the most key important points is the planning, the structural like risk management, and then the post dive processing of those data or samples. That's really the key difference that people don't take into account when they start talking about scientific diving. They focus on just the diving bit, not the scientific bit, and that takes priority or precedence.
How about yourself? Do you also run scientific projects, or are you only focused on the training?
Yeah, so a large component of my work is actually working on different projects around the world. Thankfully, I mean, this is what I actually, before the COVID pandemic, this is what I did. I worked as a scientific diver and logistics consultant for research exploration projects. So I used to travel around the world and do on different projects for 4 weeks, 6 weeks, couple of months, and then train scientific divers in between. Obviously, the pandemic closed down all those opportunities. And then during that period, the actual funding for this Finnish Scientific Diving Academy started, and I was employed in 2021 to start this entire new direction of scientific diving within Finland. And now those projects are starting up again, so I'm running them quite a lot. So last year I was on 3 projects. This year I've got one or a couple coming up this year, actually.
Do you have a memorable one that you can tell us about?
Oh, I've got two really memorable ones. One is one of the first big ones I did, which was in 2015. We went to the Bay Islands, off one of the islands in Honduras, and we were doing a mesophotic project looking at, well, it was a combined project looking at lionfish populations moving down deep because of the invasive species issue they have there. And we were sampling all the way down to 100 meters. And then the other component, the more important component, was we were working with a refugee hypothesis, which is looking at, as you get heavy impact on the shallow reefs, whether the corals and the fish species move deeper to escape the anthropogenic impact or the climate impact on the surface, the shallower reef. I came as the dive safety officer to go and run this project, and it was one of the first ones using rebreathers. So that was with the University of Oxford, with the research group at that time. Ironically, the professor that ran that project, which was Alex Rogers, moved away from the University of Oxford in the following years after that, and I actually worked for him in November, December, in his new role, and ended up having my other very memorable project, which was the Ocean Census project in the Canary Islands in the Atlantic. And that project is a 10-year funded project by the Nippon Foundation in combination with Necton, which is a foundation from the UK that work in deep sea research and conservation. And we were sampling, the Ocean Census goal is to sample new species around the world to try and find new species that we've missed in our taxonomy and speed up the purposes of taxonomy, because you don't know if something's gone extinct if you didn't know it was there in the first place, which is a very sad way to approach it. So it's a 10-year funded project that does everything from submersibles to ROVs to technical diving teams. And I run the technical diving teams for Ocean Census under the Academy. And this project was really exciting because we were working parallel with the submarine. So the submarine was doing the deeper ranges and we were doing the slightly shallower ranges, and we'd wave at each other as we went past. And it was really exciting to show the real power that rebreathers have in the techniques that we were using, and if they're done properly, how effective it can be in terms of having well-trained teams and sampling. So we had a really exciting project there. I've got other projects, like some of them I can't talk about because I've got big NDAs and everything enclosed on them. Other ones are really interesting. I was up in the Arctic doing cosmic ray sensors under the ice, and we were moving this sensor system around for cosmic ray readings. I've done some really cool work with shipwrecks in the Baltic. I'm actually just finishing up a paper with some co-authors at the moment on a wreck that we discovered in 2020 that was built in 1636, and it's upright, complete in the bottom. So we actually identified the date because we found the inscription plate with the date that it was built and its name plate on the back. So that was a combined of a team that I work with. I've done some other really interesting stuff. I work with the Estonian Maritime Museum and Finnish Heritage Agency doing survey work sort of here and there on undiscovered shipwrecks in the Baltic and documenting and trying to identify them. So each year we find a few new ones and go and work on them, and occasionally we bring up some artifacts to look at, things like that. So
Wow, that sounds like really interesting work. And do the conditions in the Baltic allow for, I suppose, for the preservation of these shipwrecks more than in other places?
yeah, I mean the Baltic it's quite fresh water, or it's brackish when you get towards the Gulf of Finland. It's not very heavy saline. It also has very low oxygen content down deep, and it has no shipworm, so it doesn't have the boring mollusk that eats and degrades wood that you get in sort of the full marine systems around the world. And as such, with this low oxygen conditions, it's cold, it's dark, very little biological activity. The shipwrecks stay, and some of them are in absolute perfect condition. Others, they've been hit by trawl nets over the years, which is, again, why the Baltic has such a focus for the ghost diving, because there's a lot of trawl nets on wrecks and things like that. And the Gulf of Finland is sort of the further away from the entrance down near the Sounds. So again, it has very, very good preservation for shipwrecks. So, I mean, there's lots of old wooden sailing ships and both world wars and everything in between with all those components as well. There's all sitting on the bottom. It's basically, I mean, I'm biased, but I think it's the best diving. The best diving in the world is that, and that's also why we focus on archaeological work in the academy so heavily, because the Baltic has a very, very interesting biological component to it, but it has some of the best preserved heritage in terms of maritime sort of shipwrecks and harbours and everything else. So we have within 20 minutes of where the dock where the boat is at the research station, I've got, I think, somewhere in the area of 30, 40 shipwrecks going back 400 years. And a lot of them are broken up, and you can see the ribs and things. They're not perfectly intact like the one that I'm working on down deeper, but they're still there, and they're great opportunities for these students to go and look at the heritage training for it as well. And then we're starting to do a lot of dual discipline, so like climate change, anthropogenic, like heat waves causing degradation to this heritage because it's increasing biological activity, the water's getting warmer, certain things can grow on it more, the wave actions can cause the breakage. So we're actually monitoring some of these wrecks in combination with the biological component, and that's where those two skills come together as well. So it's not all individual discipline anymore. That's the interesting part of it.
So interesting. And this is a side question out of my own curiosity. For the Bay Island research that you did they find that the corals and whatnot move deeper?
It's a long time ago. I can't remember what was in the paper.
Oh, okay. No
Yeah,
worries. I was just
no,
curious.
I think they found certain species were moving deeper. I can tell you the lionfish were moving deeper. The schools of them that were down there. But I mean, this is 10 years ago almost that we were there. So, but yeah, I mean, they were the
But the
size of.
lionfish are invasive themselves.
Yeah, so the lionfish were there, but they're also because of the hunting and everything of them in the shallows. We were seeing what it looked like down deeper. So we weren't just hunting them; we were looking at aggregations of them. We were measuring nearest neighbor and things like that. And I mean, they were just getting bigger and bigger as you went deeper because they're eating everything and nothing eats them. So it was quite interesting, but it's also quite challenging because if you're collecting lionfish in the shallows and you get stung, you can just go back up to the boat and deal with it. If you at 80 meters and you've got 2 hours of deco on top of you, then it makes life quite interesting. So risk assessment management was also quite exciting there. So
Wild. That's really interesting. What kinds of changes, impacts, and results have you seen from people following the training? Any fun feedback that you can share?
I mean, I've seen some very, very big changes from our training from our graduates. I think we had one student. She came in because we have a foundations program as well, which is a non-diver can do a 2 week like open water, advanced open water, very intensive, longer courses beforehand. And she did that, and then she finished the 2 weeks. And I actually had a scholarship that was left over for the occupational program that started the week after. So I offered it to the 3 girls that were on this course and went, well, there's one spot if anyone wants it next week if you want to do the 6 week program fully funded. And she went, yeah, I'll do that. So she went into it. So she started as a non-diver, and then she started this as she was a bit worried because everyone else was coming in with different background experiences. She finished the 6 week program, did really, really well. From there, she went off to Hawaii on a student exchange, and everyone thought that she was some super experienced diver and everything because she'd been hammered so heavily through this program. And she now works full time as a scientific diver, and she's worked for Metsähallitus, which is the Forestry and Park Service, doing biodiversity surveys. I don't know where she is at the moment. She was going to Belize. I haven't spoken to her for a while. But just seeing this a complete change of non-diver through this program to dedicated, like professional scientific diver, traveling the world, working on projects. And it's not just her.
Changed her life,
Yeah,
essentially.
basically, yeah. I've got a couple more now that have actually come back they're not so interested in the answering their own research questions. They're more interested in doing a job like mine, being a facilitator for operations. So they're now going, actually, there's a career here. You can do a career being a dive safety officer, or you can work in management. You can take your scientific training and skills, but you don't have to be a research scientist. You can do both. But we've also got research students that have come through that have done the program and they've changed the direction they want to do their academic career. They come in and gone, oh, I was thinking about this and that. They've completed the foundations program, they completed the occupational scientific diving program, and now they're going, well, actually, I'm going to ask this question because now I've seen that there's the possibility of answering it in a different way. And they've gone on and done PhDs using these skills. So in that sort of aspect, it's really funny. I have one guy actually. He was a very amusing character through the course. He was one of those characters that just nothing really fazed him. He's coming back now as my intern. He got a grant to be an intern for 3 months with the new program to come through. So he's a qualified scientific diver, but he's also still working his way through his academic training. So he's coming back, and he had this whole joke all the way through the program that he really wanted to drive the Scientific Diving Academy's boat, which the students are not allowed to do. And he's like, one day I will drive it. So now he's coming back and he's getting the right to drive it. So he'll be super excited from that. But in terms of the large scale impact of it, in a serious note, Finland was one of the leaders in scientific dive regulation and structuring in Europe back in sort of the late 90s, early 2000s. They were one of the driving 7 countries in Europe that brought in the European scientific diving regulations as they were. And they've always been very, very strong in that field. And then around the mid 2000s to 2010, it all dropped off. All the school, like the training, all just disappeared. Basically, the commercial school offered like a scientific tag on to their commercial divers, and that was sort of where, and even that sort of phased out. And there was no one doing the training, which is why the academy restarted. And since the academy's restarted, we've really had an influence on not only the way the scientific diving training is done, but also the collaborative work with other institutions around the Baltic and worldwide. And there's this newer generation of people coming through that are really going to make a huge impact, because we can modernize the scientific diving world, and we can really we can act as a sort of a flagship campaign as part of that overall field of driving it forward. And the students that I'm training are the ambassadors for that. And of the students that I've actually trained through the program, I think it's 90% of everyone that's completed the program has ended up working in scientific diving, whether it be for a government institute, whether it be going into research themselves, whether it be finishing a research degree, or whether it working for an environmental assessment company or something like that. But they've all ended up working in it. And that is, I think, shows as a result there's a need, and there's really a good demand for it.
I think that's a fantastic way to wrap up today. Thank you so much for joining me. The work that you're doing is so interesting and so beyond anything that I ever considered. So thank you for sharing it today.
No worries. Thank you for having me on. I'm always happy to talk about scientific diving and bring a light to it. And it's really been a pleasure to talk to you and the Healthy Seas podcast in general. And I look forward to listening to future episodes with other people that probably are more interesting than me. Thanks very much.
No, not at all. Healthy Seas is a nonprofit on a journey from waste to where. Founded in 2013, the organization aims at reducing marine litter caused by lost fishing gear through cleanup, prevention, and education activities. The nets collected by Healthy Seas are subsequently reused and recycled and used by its partners for the creation of new products.